All right, we're continuing to talk about the celestial sphere. And we just talked about that, how on the Earth you have the North, the South Pole, and the equator. Those are our reference points. And we've just extended them outward onto the celestial sphere. Straight above the North Pole of the Earth is the North Celestial Pole. Straight above the South Pole is the South Celestial Pole. And straight above the equator is the celestial equator. So, now we're going to go and we're going to look at what it actually looks like when you go outside at night and look at the stars. So this is my astronomer. Didn't really put him in the center very well. This is my astronomer, Herb. So this is Herb the astronomer. And he's standing outside at night looking up at the sky. And we're going to make some reference points, or what we call cardinal points here. We're going to put north to the left, south, east, and west. So when you go outside at night, you need to be able to tell yourself which way is north, south, east, and west. Okay? North, remember this is the same Herb, that Herb is that Herb. We're just looking at a different perspective. This is north is directly towards the North Pole of the Earth, south is directly to the South Pole, east is 90 degrees from that, and then west is 90 degrees the other way. All right, we need to make some definitions here. So we're going to define this. My picture's not very good here. We're going to define some things on this graph. So this is the celestial sphere that an individual would see. The bottom part here, or the ground, we're going to call the horizon. So the horizon is the ground that goes all around you, and we're always going to arbitrarily assume our horizon is perfectly flat. In reality, as you go outside and you look and you have buildings and trees and stuff in the way, and your horizon is not perfectly flat. I mean, the only time it's really good is if you're out in the middle of the ocean, then you got a nice, perfectly flat horizon. But that's what we call the horizon. Okay? This line right here, we call the meridian. Okay? Don't get this confused with the prime meridian. This meridian is the most important line to astronomers. The meridian is this imaginary line that goes from the north point of your horizon to the south point of the horizon, but it goes directly through overhead, which has a special name. It's called the zenith. So straight up is the zenith. So if I'm facing to the south, this would be an imaginary line that goes straight up through the tops, through the back, and down to the north point. So it goes from north to south through your zenith. We call that the meridian. You've probably, in fact, I know you've already used this, you just didn't know you were using it. When you say it's like 10 a.m. in the morning, what does the AM stand for? AM technically stands for ante-meridian, or before the meridian. And PM means post-meridian. Because when objects rise, like the sun, it's going to rise in the east, it's going to go up and get to its highest point. Its highest point occurs when it's on the meridian, and then it's going to go down again until it sets over here in the west. So over here, AM is what we call before meridian, PM is after meridian, or post-meridian. So that's where it comes from. So make sure you know what the meridian is. And this is the horizon, and these, technically, we call these the cardinal points. North, south, east, and west are the cardinal points. All right, so what we need to translate is what we see here. How does that relate to this over here? Meaning, here's Herb. And so we're going to do this for Herb in Commerce, because it depends on where you are, what you see. Remember, Commerce has a latitude of 33 degrees north. Just memorize that number. Okay? Well, what we're really seeing is Herb is seeing this half of the celestial sphere. So this is the sphere here. He's seeing that half. And I just drawn it like this so our ground is normal. That's where horizon, the word horizontal comes from horizon. Always flat like that. All right, so how does this translate to that Herb? In fact, what we want to know is, can Herb see the North Celestial Pole if he's in Commerce, Texas, at a latitude of 33 degrees? The truth is, yes, he can see the North Celestial Pole, and currently we actually have a star close to the North Celestial Pole. The star close to the next North Celestial Pole is Polaris, this star right here, also known as the North Star. And so that star just happens to be close to the North Celestial Pole, and that just happens to happen at this time. We will talk about that in the next video. But right now, there is a star there. We're real close. It's like 0.7 degrees off, but close enough for us. And we call it Polaris. And it just so happens that if you figure out this angle right here, from the North Celestial Pole to the horizon, that angle is always going to equal your latitude, or this angle and this angle are always the same. If you're into geometry class where you had to do proofs, you could do a proof and prove that was the case. But in here, you just have to know that that's the case. So what I'm going to do is draw on my Herb diagram here an angle 33 degrees up and put the North Celestial Pole here, or NCP, North Celestial Pole. So far, so good? All right, remember, critical here. This angle always equals your latitude. Okay? So put that in your notes. This angle always equals your latitude. Alright, so we know where the North Celestial Pole is. So we know where that point in the sky is. Can we find the celestial equator? Well, how many degrees is it from the North Celestial Pole to the celestial equator? It's always going to be 90 degrees away. So if I go over here, so that I make an angle of 90 degrees, and then the celestial equator is actually a curve that goes like this. A little carried away there. This is the celestial equator. And notice it goes from straight east to straight west. And this angle between the two is always going to be 90 degrees. Between the North Celestial Pole and the celestial equator is always 90 degrees. So far, so good? Good. Then what we really need to do is figure out the altitude of the celestial equator. Altitude, another definition here. This is an astronomical definition. Altitude is how far an object is above the horizon. And so it's an angle that usually goes from 0 to 90 degrees. Now it can go negative, it can go below the horizon too, and sometimes we use that and we're like, oh, the object is at negative altitude. That means is you can't see it yet. You can only see it when it's a positive altitude. So it's how far it is above the horizon. So if we look at this, the zenith, which is straight up, is actually at an angle of 90 degrees from the horizon, so that would have an altitude of 90 degrees. What we want to find out, figure out in here, is this. We want to know what is the altitude of the celestial equator from Commerce, Texas. This is actually easy to figure out because this is half a circle. How many degrees in half a circle? There is 180 degrees in half a circle. So that whole thing has to add up to 180, or I'm going to say, oh, all these three angles, that angle plus that angle plus that angle, have to add up to 180. Or I'm going to do 180 minus 33 minus 90 must be equal to the altitude of the celestial equator, which in this case is 57. So you're always going to start with 180 You're going to subtract, this is the latitude. And you're going to subtract 90 because there are always 90 degrees in between there. So the altitude of the celestial equator from Commerce, Texas, the answer is 57 degrees. Okay? All right. Now I'm sure you're asking, why do we care? This is why we care. When you go outside, and if you went outside and watched the stars at night for a long time, so here is Herb again. I'm just going to draw a new one because that one's getting kind of complicated. Right? Here's the North Celestial Pole. Here's the celestial equator. This way is north, this way is south, east, and west. We always draw north to the left for consistency, so you don't get confused. What I'm going to show you is if there was a star rising in the sky, so there's a star that rises right here in the southeast. What is the path it's going to make across the sky? Well, it's going to make a path across the sky that makes a circle that always parallels the celestial equator. If we have one up here, it still always parallels the celestial equator. So by knowing the altitude of the celestial equator, the angle there, all stars are going to follow that same angle. No matter where they are, they're always going to follow that same angle. Or in Commerce, they're always going to have a 57-degree angle, their path across the sky with the horizon. So stars down here we won't see very long because they're going to make a little path like that. Now if you get a star up here, it's going to make a circle around here. They're all going to rotate around the pole.